So, uh, today in your course, right? So today we will be dealing with the experiment which deals with operational amplifier. So let me check. Experiment number 5 was experiment number 5. Just 1 second, okay? Uh, experiment number 5 is
Experiment number 3, sir.
no.
Two, sir. Is it right?
No, this is experiment number 5. So experiment number 5 should be operational amplifier, okay? So this is your experiment number 5. Now this is according to the new sequence, right? Don't get confused, right? Here you will submit. See, regarding submission, one important notification. For example, let us say I'm here. I have experiment number 5, right? So these three people, Aditya, Anant, right? So when did they handed in the experiment, right? So they handed it on 18th of December. Okay, so I will not consider this thing because I have changed this thing. This was experiment number 5. This is design of rectifier, right? Using PN junction diode. So it is totally wrong. Okay, this you should submit here where uh, that was your experiment number. So for example, design of rectifier, right? So this is experiment number 3. Okay, so here all of you have submitted this design of rectifier. Okay, so even though this even though this was experiment number 6, right, but this is design of voltage regulator using Zener diode. So just we will check it. What is experiment number 3 exactly? So this is voltage regulator. So perfect, right? So even though I want whatever there is given assign जो असाइन किया है ना, जैसे फॉर एग्जांपल असाइन क्या किया एक्सपेरिमेंट नंबर 3 में किया वोल्टेज रेगुलेटर, मतलब जीना डायोड वाला एक्सपेरिमेंट मैंने असाइन किया है, तो यहाँ पर आप जीना डायोड का ही राइट अप आप अपलोड कीजिए. ओके, now experiment number 5, right? Here I have assigned you the experiment of maybe linear integrated circuit or op-amp. तो यहाँ पर op-amp का ही कीजिए. Okay, right? So this you should what you can say, you should upload here the write-up of operational amplifier only. Okay, and if you are not uploading it, okay, then there is some problem. Okay, so for example, let me Aditya Anant, right? So he had not read properly that which is the experiment number. Okay, he have randomly see experiment number 5, it is okay, but just match the title. This is PN junction diode. Okay, so uh, I can just write here, please remove this and upload it in proper respective to signed work. समझ में आ रहा है मैं क्या बोल रहा हूँ? Yes, no?
Yes, sir.
Okay, so this is the problem. Okay, this will not be considered because I want you just match the title, don't match the number. Okay, आपको at least जो आप जब आपके पास जब असाइनमेंट आता है तो उसमें एक्सपेरिमेंट नंबर भी दिया रहता है और नेम ऑफ द एक्सपेरिमेंट. सो मैच नेम ऑफ द एक्सपेरिमेंट, राइट? And this I will not give a comment to each and everyone. Okay, this is I'm giving in a I'm giving in a if you want to say anything, please put it in the chat box. Okay, don't unmute and say. So I will not what we can say, I will not mail this comments to each and everyone. This is I'm getting it into the recording so that maybe this mistake no one will do. Is it okay? I guess it is clear to everyone. Okay, great. So I can see chats, right, in the other window. Yeah. So let me today let us concentrate on the experiment. The name of the experiment is design of inverting and non-inverting amplifier using operational amplifier. Okay, so let me give you a brief idea regarding what we will be doing. So in theory we have covered what is operational amplifier, right? So can you tell me what is operational amplifier? So let us say that this is your basic operational amplifier, and then there are two inputs and there is one output. Okay, and one of the input is inverting, another input is non-inverting, and then there are two power supplies, right? Two power supplies, one is plus VCC, one is plus VCC, and another is minus VCC, right? So how to apply the power supply to the how to apply the power supply to the operational amplifier? Very very right. Okay, uh, so first of all, I will just tell you what is inverting and what is non-inverting amplifier. Okay. So basically, the thing is that there is a feedback. So we will use negative feedback. Okay. So output is connected to the input. Output is connected to the input, and then I'm putting here some feedback element. Let us call it as resistor. RF is the feedback resistor, and then there is another resistor called as input resistor, RI. And yes, now this is one circuit. Okay, this is a feedback circuit. Now let me just copy this circuit. Let me just copy this circuit. Okay, and I will just add it to new page. Okay, and I will go to okay, so this is a circuit. Now let us see first configuration, and your first configuration is your op-amp as a non-inverting amplifier, right? Or let us say inverting पहले ले लेंगे, inverting, right? So inverting amplifier. So what is inverting amplifier? Input is given to which terminal now? Inverting terminal, right? So this is your inverting terminal. So here I am giving the input. So let us suppose this is your input V in, and then this non-inverting is connected to ground, 0 volts. So we know this voltage is V1, we know this voltage is V2, and V1 is equal to connected to ground, and by concept of virtual ground, V1 is equal to V2. This we have seen in the lecture. So that's why this voltage is also 0 volt, and then whatever current is flowing in input resistance, that is I, and whatever current is flowing in the feedback resistor, that is IF, right? And then we have the equation I in is equal to IF, and then we have solved this thing and we came out that the V naught by V in, that is gain of the amplifier with feedback, right, of this non-inverting amplifier is what? It is nothing but minus RF divided by R in. Okay, R in or Ri. Okay, let me call it as R in, input resistance. Okay, so yes, this is your inverting amplifier, and also we have seen that let us say that this RF is equal to 10 kilo ohms and Rin is equal to 1 kilo ohms. Okay, so this AF will be minus 10, right? 10k by 1, that will be minus 10. And then you know that if V in is equal to 5 millivolt, right, then V out will be equal to V out, or V naught will be 10 minus 10 multiplied by 5 millivolts, that will equal to minus 50 millivolts, right? So ये हमने lecture में देखा था, right? One important thing, okay? This was regarding non-inverting amplifier, and gain is nothing but minus RF by Rin. Okay. Similarly, I can tell you about the non-inverting amplifier, right? So in non-inverting amplifier, this is your non-inverting amplifier. Okay, so previously one more point is remaining, that your output is minus AF times V in. So due to this minus sign, we can say that between input and output there is 180 degrees of phase shift. Means if I am giving a sine wave, I am getting an amplified version of sine wave, but there will be 180 degree phase shift between the input and output because of this negative sign. Okay, and similarly, if we consider about non-inverting amplifier, means what? I am giving the input at the non-inverting terminal. Okay, so this is your V in and this is your R in. Okay, and this is connected to ground. So V1 and V2 by concept of virtual ground both are equal, and that voltage is equal to V in. And again we have seen that I in is equal to IF, because current in the amplifier is equal to 0. So in the lecture, we have seen I is equal to IF, and then we apply the Ohm's law, and then we derive the equation of V naught by V in. that is equal to gain of the amplifier with feedback, that was coming as 1 plus Rf divided by Rin. Okay, so this is again this is your non-inverting amplifier, and again we, if we consider a simple case, if Rf is equal to 10 kilo ohms, if Rin is equal to 1 kilo ohms, right, and if Vin is equal to, let us suppose, 5 millivolt. Okay, so what will V naught will be AF times what is gain, 1 plus RF by Rin times, right, AF nahi to fir 1 plus RF by Rin times Vin, right, so it will be 1 plus 10 by 110, that is 1 plus 10 times Vin, that is 11 into 5 millivolts, that is 55 millivolts will be the output. Okay, and then we can say that output is V naught is equal to plus AF times Vin, right, here AF is nothing but 1 plus RF by Rin. Okay, so we can conclude that the both the input and output are in phase, that is they are 0 degrees out of phase. Okay, or we can say output and input both are in phase. इसका मतलब ये है कि if I am giving input as sine wave, output also I will get sine wave, but just amplified version of it, right? So this is regarding non-inverting amplifier, and this is regarding inverting amplifier. So both the cases we have seen thoroughly in detail in our theory class. Okay, now very important concept. Okay, now what is remaining is that we have not given a power supply plus VCC minus VCC. Okay, so let us give the power supply. Let us suppose that you are having a power supply here, you are having a power supply here. So how many power supplies we need? We need two power supplies. Okay, so we need two power supplies. So let us suppose that every power supply will have two terminals, right? One is your positive terminal and another is your negative terminal, positive terminal, negative terminal. Let us suppose this is power supply, this is also power supply, and this is, let us suppose, 15 volts, this is also, let us suppose, 15 volts. So how you will give the power supply connections? देखिए, very important aspect, right, of connection. So I will make a bold line for it. Uh, I will use maybe a red color for connection. Okay, so the thing is that yes, this this positive plus VCC is connected to positive of one power supply. So how much voltage is available here? Plus 15 volts. Okay, और यहाँ पर minus 15 volts के लिए हम क्या करेंगे? We will give minus 15 of another power supply, क्योंकि दो अलग अलग power supply है. Okay, and now you know there will be some ground, there will be some ground somewhere, ground in the circuit, right? So let us suppose this is ground. So what we will do, you know, we will connect, we will connect this negative, we will connect this negative of the power supply, we will connect this negative of the power supply to ground, and we will connect positive of the power supply to ground, right? Or we can say that we will short both the positive and negative of both the power supplies and connect to the ground. So like this we need to give the power supply. So this is called as dual power supply, or we are calling it as applying the power supply to the operational amplifier. So how many power supply we need? We need two power supply to give the power to the what we can say, we need two power supply for giving the power for uh, or let us say for biasing the transistors which are inside this IC, or inside this operational amplifier. And which is this IC? This IC is nothing but your IC number is IC 741, which is this IC 741. Okay, and let me go back to the write up. So I guess that till now you have understood all the things. Yes, no? Please reply. Okay, great. Okay, so good. So till now all the things are clear, and now let me go back to our write-ups. And okay, where is the cursor? Okay, yes. So here it is. Here the write-up is there. Okay, so what we need to do, we need to design the inverting and non-inverting amplifier. Whatever we have done it theoretically, we need to do it practically. Okay, so the objectives is to get familiar with the operational amplifier. We will use IC741, right? We will measure the gain of the operational amplifier, and this is the theory which have been covered. Okay, and then Let us say that if this is the symbol, okay, and if I want to apply the input, inverting input, right? So where I can apply it, at which terminal, or at which you can say pin number. So this is pin number 2. Non-inverting is pin number 3. Output is pin number 6. Plus VCC कहाँ पर देना चाहिए? Pin number 7. Minus VCC कहाँ पर देना चाहिए? Pin number 4. So this pins we will be using when we will use the IC. Okay, and then these are nothing but the characteristics which we have covered in the class, right? Practical and ideal characteristics of the operational amplifier. Okay, and then this is the circuit which I have just recently explained, the inverting and non-inverting circuit of the operational amplifier. And then let us say this up let us what we can say, let us give some let us calculate the output voltage. Okay, and these are the values. Okay, so let us say that this is your inverting amplifier. So this is your inverting amplifier. So what is gain of the inverting amplifier? Can you tell me what is gain of inverting amplifier? AF is nothing but minus RF divided by RIN, right? So gain is nothing but, what is this? This is your R2 is nothing but your RF, and this is your R1 is nothing but RIN. So here gain is 100 by 10, so gain is 10. Is it correct? Yes. Then 80 by 20, gain is 4. Minus sign is always there. 30 by 10, yes. So this is the theoretical calculation of the gain. Now let us do it practically. So how to do it practically? So I will just put here, I will just add here Tinkercad, uh, and I will log in it by using my, I will sign it. I'm signing it by using my Google account. I'll just remove this part. So I'll sign it with my official ID. All the circuits are available. This is your circuit. I will create a new circuit, right? Even though I'm having the circuit from last year, but I always do it a new circuit. So you also try to do it by your own. So what we want a breadboard first of all. So let me take a breadboard, and then you want operational amplifier, right? So you can just take Opamp. Operational amplifier, okay, or you can just take the name of this IC called as IC741, right? आपने अगर IC741 डाला तो भी यही आएगा. Okay, so this is your IC741. Okay, so this you need to use it as an operational amplifier normal, so you will be using this op-amp. Okay, and then I can, if I want, I can just rotate it. Let us say for our convenience, I'll just rotate it. Okay, so I've just rotated it because I just want it to be simple. Okay. Now, first of all, I will apply the power supply. So power supply, how to apply it? So we know that we need how many power supply? Two power supply. So power supply. So we need two power supply. So this is your plus VCC, another is minus VCC. So let us say that this is, let us say I'm giving here 15 volts, and this is, let us suppose here also I will set the same voltage, that is 15 volts. Okay, so this thing plus VCC, if we go and check here, if we go and check here, plus VCC is connected to pin number, plus VCC is pin number 7. Okay, so I'll just go here, and this is your plus VCC. Let me connect it to pin number 7. So this is your pin number 7, right? Power plus, correct? So let me give it some color, some different color, purple color. Okay, and then minus VCC, we are just connecting it to minus VCC, we are connecting it to this is minus VCC, we are connecting this to pin number 4, I guess. Okay, 2 and 3 is plus VCC. So this is power supply minus, correct? And then the positive terminal of minus VCC and negative terminal of plus VCC, they are connected to a common point, call it as ground. Okay, so let me say that that this this complete line, this complete horizontal line, green highlighted line, this is your ground connection. Okay, So I'm just giving the positive also to a ground. So I hope that this is clear to you. Now you know, now I can say that I have given the power supply to the operational amplifier. Okay. Now if I want to measure the voltage at the output of the amplifier, I will use voltmeter. So instead of voltmeter, let me use multimeter. Okay. So I am using here multimeter just to check out, just to check out the voltage between the output terminal, and output is at terminal number 6, right? So let me check. Yes, so this is your out terminal. So I'm just checking the output, and let me give it some orange color. Okay, and this negative I'm connecting it to ground, because output is always connected between the output terminal and ground. Okay, so this complete highlighted green color line is your ground connection. Okay, and I'm just connecting it to a black color. And now I will just run the simulation. I will just run the simulation, and as we can see that you are not getting any output. So yes, perfect, this is your ideal amplifier. But you know, in practical cases, if you are giving the if you are giving the power supply to the operational amplifier, and if you check it practically by using the multimeter, there will be some voltage in the output of the amplifier. Even though we are not giving the input, we are getting the output in the multimeter, that is in very very small voltage, that is in millivolt. And that voltage we call it as offset voltage. Okay, so that offset voltage I can show you practically. Okay, but not here. Okay, so I will just remove this thing. I have just told you that how to check the offset voltage, but yes, that is not needed. Now, second thing is that yes, we need to give a input signal, right? So let me give here input. Let me give here input. Input we can give it by using function generator. Okay, input I can give it by using function generator. Okay, so let me give a input. Let me give the input to 1 second. Let me give the input to inverting first. So this input I'm giving it to, this is your inverting terminal. Okay, so I'm giving the input to inverting terminal. Okay, and let me give the color of input as let us say that it is green. Okay, and then okay, but before giving the input, there is one thing that we need to give the input through a resistor. Okay, so I will just use a resistor here. I will just use input resistor. Okay, so I want a resistor, two resistors I want, right? So here there is a resistor. So I will take this resistor. I want to connect it between input terminal, right? So this is your, okay. So I will just keep it aside, okay, for your understanding purpose. Normally, this is your simulation. So okay, I can put it anywhere, not a problem. So through input resistor, I am giving the input. So I am giving the input to inverting terminal, right? So I will just drag it down. Just 1 second. I'll just give it. So this terminal is connected here. Okay. Is it okay? This are shorted, right? Vertically shorted. We know that. Okay. And then one more resistor is there. That is your feedback resistor. That is connected between output and input. So again, you know, there is one more resistor which I will take, and I will just put it here only. Okay, for your understanding. So this terminal is connected here. Okay, and this terminal is connected here. Okay, just 1 second. I will just, this I will be connecting it to output terminal. Which is output terminal? This. So here I can connect it. Okay, and this is also connected to output because this was your plus VCC, right? So this is power supply. Okay, this was what okay. So this is your output terminal, right? This is connected to output terminal pin number 6. If we see the dot, right, you can see pin number 1, 2, 3, 4, 5, and 6. So here output terminal we have connected this, and let me give it as some name called at RF, and let me call it as 10 kilo ohms, and this is your R in, R small in, and this is 1 kilo ohms. Okay, and then let me give some input voltage. Okay, and output, where we can find the output, so we can just get the output either on oscilloscope or on multimeter. So I will use another oscilloscope so that I can view it properly on the scope. Okay, so this output is connected to the oscilloscope. Let me connect it. Let me, okay, with some blue color, and this negative terminal output is always taken between the output terminal and ground, so let me connect it to ground. Okay, and then what input I will give, let us say one, uh, so this is your 50 millivolts, or let us say zero point 0.5 volts. Okay, and offset voltage I will keep it as 0 as always. Okay, and I will use sine wave. So yes, now input you can see and output also you can see, and let me simulate it. Let me simulate it. Uh, so it will take some time. Just a second. Okay. So it is 1 second. So we need to change it to 1 millisecond. 1 millisecond. Just I will start it out. Oscilloscope is not able to show. Okay. Let me. It's nanovolts, right? So something is wrong. Just let me check it. What's the problem? It's taking very less current. I'm getting the output here. I'm giving the, okay. Just 1 second. Huh? So what is problem? Can anyone tell me? इनपुट हमने दिया ही नहीं ना, राइट? इनपुट दिया है, लेकिन ये जो सुनिए, इन्वर्टिंग एम्पलीफायर, सो इन्वर्टिंग एम्पलीफायर, लेट मी गो बैक हियर. So have we done all the connections? So this is your inverting amplifier, this we have done, but this we have not connected, right? ये जो आपका positive terminal है non inverting, that we have to connect it to ground, correct? So here also, you know, here also what we will do, this inverting terminal we need to connect it to ground. Okay, and which is ground terminal? This is the ground terminal. Okay, so I'm just connecting this terminal to ground. Okay, now let us simulate it. So this is connected, right? This is connected. Okay. The output is also there. All the things are proper. Okay, let me do one thing. Instead of function generator, I will just use a normal, I will just use normal power supply. Okay, I will use a power supply. I will use a power supply for input, and I will just use multimeter at the output. Okay, because I will use multimeter at the output. So this positive terminal is connected to the output. This is your output terminal, right? Let me give it as some another color, and this color, this I will give it to ground. And here at the input end, at the input, I'm giving the input here, and this we need to connect to the ground. Okay, so this is your black color. And now sorry, this is black color. Okay, and now this is your input, so let me give input as 0.5 volts. Okay, and here I should get the output, so let me start simulation. Great. So yeah, यहाँ पर आपको direction भी मिल रहा है, so we will use the same configuration. So here in the experiment, can you see that this is the experiment, right? Where is the write up, by the way? Yeah, so sorry. So this was the write up, right? So so this is your inverting amplifier. So my reading was how much voltage I have given, 0.5 volts, right? And then what is the output voltage I am getting as minus 5 volts, right? So minus 5 divided by 0.5, how much it is? It is minus 10. So like this I am calculating the practical gain. So I think is it clear, all of you? Yes, no, please type it as yes, no. Okay, okay, great. So I will just answer all the questions. Just let me complete with another circuit. So yes, is it clear, all of you? Yes, Gaurav Kale, just type your question in the chat box. Okay. Calculation part is very simple, right? Calculation part, this theoretically we are getting for this inverting amplifier. What is the theoretical gain? RF by Rin. Okay. So what RF we have considered 10 kilo ohms. What Rin we have considered 1 kilo ohm. So 10 kilo divided by 1 kilo. This is your theoretical gain of the amplifier. Now let us go and check it practically. Practically we have set the gain 10 kilo ohms, 1 kilo ohms, right? So practically we are getting minus 5 volts as output, and input is 500 millivolts. So 5 minus 5 divided by 500 milli, it comes out to be minus 10. So this minus 10 is your practical gain, right? So theoretical and practical both are matching. So like this you can change the voltages and you can take the 5 readings. So I am expecting this all 5 readings with various voltages, right? Not only this voltage, but you can take another voltages, and then you can just see whether they are matching or not. Okay, now this was your inverting circuit. Okay, you can save the circuit, and again you can do some another circuit, but I will change the circuit here only. Okay, so in inverting, what is the thing? In inverting, this was the inverting, and in non-inverting I will directly give the input to the non-inverting terminal, and this I will connect it to ground. Okay, so here what I'm doing, instead of giving input to non-inverting terminal, I will connect this terminal to ground, right? I'm connecting this terminal to ground. Okay, and input, right? ये जो ground है ये मैं निकाल देता हूँ, and input, now I'm giving the input to the non-inverting terminal. Directly I'm giving the input to the non-inverting terminal. So this is your non-inverting, that is positive terminal. So here I am giving the input. Let me give it by using green color. Okay, green थोड़ा overlap हो रहा है, so let me give it by using some brown color. नहीं, Turkish. Okay, so this is your second input. Okay, with this Turkish color. Now I will just see what is the right. So let me give some another value of input. Okay, let me give it as zero point 0.4. Okay, so no problem, zero point 0.4 I will give, and this is your 4.40 output. Okay, so what is the practical gain, sorry, theoretical gain क्या हो गया अभी? What is theoretical gain, can you tell me? So see, the output is 4.4. Let me write it. Output voltage is 4.4 divided by input voltage is zero point 0.4, so gain is 11. ओके। एंड प्रैक्टिकली हम देखेंगे इसका गेन क्या आएगा। सो इसका गेन आएगा 1 प्लस आर एफ वॉज 10 किलो डिवाइडेड बाय आर इन, सो इट इज 11। So this is theoretical value, this is practical value, both the things are perfect, so we can put it in the column, right? So here here also we can just write it down properly, that let us say that my input is zero point 0.4 volts, or you can say 400 millivolts, okay. And with this what was my r2? R2 was 10, r1 was 1, and then theoretical gain is minus, theoretical gain is minus, this is inverting, right? Okay, this is non-inverting, okay. Non-inverting with DC input, okay. So, so this was, sorry, this is minus 10, this is 10, and this was 0.4, and ये कितना आया था फिर 4.4 volts, right? You have to write the units. Theoretical practical are matching, is it correct? Yes. So this is inverting amplifier with DC input and non-inverting amplifier with DC input. Okay. So same thing we need to connect it by giving some AC voltage. Okay. So AC voltage कैसे देंगे हम? So we will just now what which configuration I am saying here. So this is completed. I will just highlight it. Okay. This is completed. Okay. Inverting inverting with inverting with DC is completed. Let me highlight it. Inverting with DC is completed. Non-inverting with DC is completed. DC means DC input. Okay. Now what is remaining? Now let us see this case non-inverting with AC signal. So here what I will do, I will just give AC signal. So I will remove this. I will remove this thing, and I will just add here AC supply. So AC supply, from where I can add AC supply. So I can just add it from using function generator. Function generator. So I'm giving here, I'm having here function generator. I have this function generator with me, and I am giving the input. I am giving the input to non-inverting terminal, and this inverting terminal I am just connecting it to this inverting terminal. I am connecting it to ground. I will use black color, and let us say that this is again 0.5 volts, and DC offset I will keep it as 0, and this is a sine wave. Okay, and I will just start simulating it. Okay, so this is variable, so we need to we need power supply, sorry, oscilloscope here. So I'll stop simulation. I will just remove this part, and I will put here oscilloscope. I'll just put here oscilloscope, and oscilloscope, this positive I am connecting it to the output terminal. So output is pin number 6. This is your output, and this negative I am connecting it to ground. So this is your ground pin. Okay. This I will do black color. Time per division is 1 milliseconds. This is 1 kilohertz frequency. Great. So I'm getting the output. Let me zoom for you. देखिए input कितना था. Now I will just see what was the input. Input was sine wave 500 millivolts. Okay. So I'll just write here. I will just write here. This is non-inverting with AC input. So this was how much it was. 500 millivolt was the input, and theoretical gain is 11, right? Let me check the output voltage. Okay, practical gain is we will calculate. Okay, so let me see what is the output voltage, and I will zoom for you. So how much it is? So 1 volt, right? So 1 2 3 4 1 2 3 4 5 5.5, can I say 5.5 volts? Yes.
Yes.
because it is, yes, because it is giving as means 10 है तो फिर 5.5 divisions cover कर रहा है, right? One division for 1 volt. So if one division for 1 volt, so it will be 5.5 into 1 volt, so that will be 5.5 volts, right? And then you can calculate the practical gain. Again it is 11, and like this I can just calculate the non-inverting amplifier with AC input. Similarly, you can calculate inverting amplifier with AC input and do all the things. Okay, so I think that this is clear to you, all of you, and I expect that you will so four cases I have covered, right? So this also I have covered, non-inverting with AC input. Now just one more thing, last thing which I'm expecting from you is that you will be doing this case, that is you will put inverting amplifier and then you will give the AC input and just take all the readings. Okay, so I guess that any problem, anyone